So might I recommend if you unplug your microphone because you're plugging in a DVD burner to burn something for your daughter, you plug the microphone back in before you go on your stream. I'm going to take that one from the top because the video editor will fix it. So that whole section will just be gone. We'll redo it. Thank you for mentioning that background. Welcome everybody to another Binary Ninja live stream. We're back, and I totally didn't just flub that intro. Totally didn't happen with the muted mic. This is the first time this is happening for sure, for real. We've got a little bit of a normal episode at the beginning. We're going to be covering some Binary Ninja news, talk about the features code that landed this week, and then we'll be meeting with Xusheng, one of the Vector 35 Binary Ninja developers, who recently won the Grand RE Challenge. So he's going to talk a little bit about that, the challenge itself. He's going to show off one of the problems that he solved with Binary Ninja and talk about that as a whole. But it is currently 7 a.m. on Saturday in China, so we told him show up at 7:30. You don't have to get here quite so early. So at some point he'll join the stream. We should hear him join. Hopefully I'll hear the ding, and he will be with us, and we'll do that. But until then, we'll do the usual updates. So let's switch on over. All right, so let's see. I was actually just going through the list of changes from this week. It's right 2 weeks ago during our last stream, we dropped workflows. Brian came on and we talked about it and showed off some neat features. That has been on dev now for 2 weeks, so it landed so everybody else could try it out just after. Or actually, I think even in the middle of the live stream is when it actually kind of hit dev. So workflows have now been on dev for 2 weeks. Just yesterday, where's my Ninja? Just yesterday, we even got some workflows up here still. Andrew landed some improved type libraries. So this is 2958 and newer, I believe. I don't know if there's been any today. I should double checked. Let's see, Binary Ninja Dev. Is it just Binary Ninja I put it in? That looks like, yeah, recently today. All right, so if we look, we should see some new type libraries showing up. Oh yeah, we're gonna have a lot of docs in Python. Here we go. So is it these? XMIPS, those, or let me see here, which one was it? I have to double check it. No, there they are, the BNTLs, right? These type libraries. So again, the files before are the platform type files, which control things like just no return mostly on syscalls. So it's a little bit confusing to have signature libraries, type libraries, and then the platform type information. But you can see here, these are BNTLs. And there should be some new ones like on other architectures. So we've got syscalls, x86, those are all the DLLs. Let's go to typelabs, let's go look at this. This one might just be the old ones. Maybe it didn't actually finish building. I might missed that. I thought I saw the commit succeeded. I'm gonna check our build infrastructure real quick because I thought that one went through. And I guess even if it did not land, it will very soon. Because I know Andrew's working on getting those out. But the idea is that there are several libraries. Oh, the test failed. Thank you. Kyle caught it. Oh, I thought I saw a follow-up commit that got those fixed. One of the things with our infrastructure is that we push and there's a bunch of unit tests, but if you improve things by say adding a bunch of type libraries, the test will fail. So you have to make sure you commit updated versions of the unit tests and make sure that they are all strictly improvements over the previous. It's the sort of the rule of it. So. Well, that one, that's an unfortunate one. I thought that was there. They are not live, but I think I know some other ones that are. So I know one that I actually added is you can now set an environment variable to disable repository manager plugins. So this is kind of like a little troubleshooting tip. If you are working with Binary Ninja and you run Binary Ninja from the command line, There's a -P command line switch, and that will prevent all plugins from loading. So user plugins, repository plugins, like all sort of external plugins, because technically, like our architectures are actually plugins, just ones that we ship with. But this will disable all of those with -P, and it's really nice if you are experiencing some problems with Binja, you can run that and just root cause to see if it's related to a plugin or not. There's also, however, some slightly lesser known ways of doing it, which is under the troubleshooting guide, I believe. Let's see if search can find it for me. Oh, I don't believe you. Disable user plugins. I know it's under here. Being disable user plugins, I think. There it is. Using and writing plugins. There we go. Oops. Yeah, so there was previously this being disable user plugins, and that actually doesn't disable the plugins from the plugin manager. So if I head over to here and we search for this, let's see, there was a couple places that got added. I think I meant to add it to the documentation of this as well, but there's now also BN disable repository plugins. Oh, right there. So there's my change. All right. And so that just documents that there's several different variables you can set. This is, whether you're doing kind of a headless automation script and you don't want a plugin to change things, like we use this for our unit tests, for example. So we don't want plugins to change which architectures are listed. We want the kind of consistent behavior so that we can use stuff like that to control it. But it's also useful for other users. I just mentioned that one because I did that. There's a new setting. There's a change to the setting schema. So you can actually have, there were several settings in Ninja before that were like magic settings. So if you changed your theme or your font size, there were certain of them that had like kind of hard-coded checks in for like, hey, you need to restart the UI for this. And that's now actually a property of the setting. So the advantage of that is before we were the only ones, we had to like change some code in the settings to deal with that. But now you can actually, it's controlled as a part of the schema, which should let you be able to say like, actually this setting is also needs to restart the UI. So it's just a little bit cleaner there. Workflows. Oh, that's right. There's another new system that I actually don't know as much about the details about. I'm looking forward to seeing. That I saw that Ryan committed involving platform identification. So the idea is that when we started, you identified like Linux and x86, and that was a platform. That was as precise as it got. But it turns out there's actually a lot of different like variants of Linux, or Linux ARM is a good example, right? There's a lot of different little embedded ARM platforms, and maybe you have separate libraries for each one, or maybe Android is, well, it's Linux and ARM, but like it's much more specific than just that. So the idea is that this is the start of a new system that allows much more specificity, and you can actually have like subtle differences that you can detect. So I'm looking forward to learning more about like how you would implement that. And the idea is that we can actually have a better variety of platform support. So let's see what else changed. Oh, the reflection view got some improvements just to keeping it syncing a little bit more consistently, I think I saw. And I think that was about what I had noticed, but let's just do a double check real quick and look for the history and see if we got anything else that I missed. Oh, so updated, yeah, workflows. There was like a little bit more work on workflows as well that Brian did, and those examples are also live. Debug info API so Kyle, I saw you were on the stream. Did the debug info? I think that got enabled in the last 2 weeks too, didn't it? I don't think that was there 2 weeks ago. Is that one a new one? So under settings, you can now parse and apply debug info. And right now it's disabled by default. It's a experimental setting, but the idea is that this will be enabled at some point, and it's going to automatically apply things like PDBs if they exist or dwarf information. So I think that one may have been a new one. I don't remember that one being. It got this fix landed a little bit ago, but I don't remember for sure what's a part of that and what's not. So we'll see what he says. Oh, that's right. Tags got some changes, and I think that was about it. Oh, Startup RC. I don't know if that got landed. That was just afterwards. Oh no, that was a change to the documentation on the RC file. Yeah, I think it was there. All right, cool. So that's a quick summary. Like no like massive earth-shattering features. Every other stream I feel like for the last 2 months it's been like, oh, major new feature just landed. Major new feature just landed. So this is the first time it's a little more chill. Although if you'll saw in GitHub, Peter has been on stream to talk about the API refactor, and that actually there's a test branch that you guys can check out early. I think it's test type hints. Type hints is the name of the test branch, and so if you want to actually look and see, it's a pretty massive set of changes. This is just in the last couple of days, and then Peter's been working on this one for a while. So oh yeah, so the API itself, so the API itself is a month old, Kyle, but is the does the dwarf parsing run? Is the dwarf parser based on that setting enabled? Like if you enable that setting, will dwarf information be pulled out and run, or is it still just a separate plugin? Was the question. So the nice thing about this is plugin authors and users, if you want as well, you can start checking out the API. You can start seeing the PyDoc generator from it. Or you can start looking through like the source code and see how dramatically things have changed. Actually, that's not a bad idea. Let's pull some of this up and let's go look at something I happen to be playing with recently, which is if we pull up the Python function object, for example. Oh, I think we might have Xusheng joining us.
Hello, Jordan.
Welcome.
Good evening. Yep.
Good to have you on. Good morning for you. I'm just covering some changes. So here, let me. I think I can pop up your video. Oh, that didn't work. Oh, I might need to change that. Let me see. Well, that should do it. That's got you there, kind of. Yeah, I think I need to fix the. Oh, I have a very, very large version that I can fix up. But I'm just gonna turn that one off for now, I think. I'll switch back over to the face cam in a little bit, but so the dwarf is the dwarf plugin in the test branch as well. They can actually build and run the Rust plugin. So it may be possible to, I don't know if you can easily build and run a test branch without access to our core test builds as well too. But so dwarf is coming soon. There's already dwarf support in the Python plugin, but we're going to add additional a separate bit of dwarf support. So let's actually look here, and I think Xusheng, you should be able to see as well the stream. I'm just going to show off some of the differences between what Peter's been doing on the test branch. So excellent. You can be my commentary too, and tell me if anyone comments and I missed it. So here is our current. This is the current one, and then this is the wait, the way around. Oh, one of these should be test type hints. All right, so let's go look at the test branch. And again, this is not complete. There's still some more testing, but it's closing in there. Let's actually split this to a new window. Okay, that actually worked. All right. This is what happened. Oh, we changed tabs. All right, let's look here. All right, so we've already got some hints that things are pun intended, that things are changed, because we see like expression index and instruction index are both being just set to int. But the reason that hey, welcome Fox. The reason that these are done differently is you can actually annotate a type as saying this takes an expression index. And even though, yes, fundamentally it's still just an int, it can actually detect if the parameter was also of that type or if it just happened to be an integer. You can actually catch some, like if you pass an instruction index into an expression index, it'll actually detect that in your type hint linter, which is much nicer than just waiting for bad behavior to show up. So you can see right at the start there, there's some of that. You notice also this 2 to 3 compatibility is gone. Like we've had some legacy 2 to 3 things left over, but we haven't had Python 2 support for a while. There's a whole bunch of stuff. And this is like a major refactor. The only downside is it's going to make git blame really hard to figure out, because it'd be Peter's fault when everything breaks. So we can just blame him for months.
Yeah.
And then yeah, see this type as well too. Function types are you can actually do like is instance of function, low level IL function, medium level IL function, high level IL function. You can actually just compare something. Is it a function type if you don't care what type of function it is? So this is extra type information. So Fox, I think the Binja demo runs on Kali. If not, let me know because I'm pretty sure that's it's been something that pops up every now and then. So yeah, and then we've actually got like it looks like alphabetical classes, although well, maybe not. No, because functions down here now, so it isn't quite that restructured. But you can just tell. Obviously, it's got type information, and so it's much cleaner in that regard. There's also a lot of shenanigans we did with setters before that I think have been refactored in some of these other ones. And so it has a lot less boiler, but actually this is a good test. What's the total lines of code? So yeah, that's the real marker of a good refactor, right? We went from 4,700 lines to 3,600 lines of code in this as a part of this cleanup. So there's a lot of useful changes. Anyway, people can check that out anytime they want. And let me see. I think originally I was going to do Binary Ninja Basics next, but I'd rather, I think, talk to you, Xusheng, um,
Yeah.
if you're up for it. So let me first switch over to video. We'll see if this works. Yeah, there we are. I got you. Everyone
Yeah.
can see you and say hi.
Is my video quality okay?
It looks great. Looks great to me. Yeah, we'll
Yeah.
see what the stream says.
Hello,
But
everyone. This is Xusheng speaking, and today I'm going to share some of my experiences with the recent Grand Prix challenge and how I solve it in Panda Ninja. It's going to be.
well,
I hope it's.
you
Mhm.
buried the lead. So it's a figure of speech that's like when you have a newspaper article, you want the most important thing right up front. You buried the lead, which is that
Mhm.
you won the competition, right? Like that's
Yeah, I won the competition.
yeah.
It's 5,000 US dollar prize, which is quite large. I mean, it's larger than other CTFs that I can win on myself.
Yeah,
Well, I mean,
as
yeah,
a solo competition. Yeah. So here I'm gonna switch over real quick. I can show the webpage for people, but this grand-re-challenge.org, and they can see right
yeah,
there. They got the winning note about you on it, and it says that you solve for the challenges. I guess.
yeah, yeah.
Well, you
I
don't you sound a little disappointed, but like you were like the top scorer, so you beat everybody else out, right?
Yes. So like we have 12 challenges, but it's quite hard, and solving four already grants me to win it. That doesn't mean I cannot solve other challenges, but I mean, I just managed to solve four of them within the time frame.
Yeah, and you
And
did have a job at the same time too, so you weren't you were doing
yeah,
other things at the same time.
yeah, of course. Yeah, I love writing Binder Ninja.
And you're currently working. Actually, you want to talk about that a little bit too, about what you're working on for that?
Oh, I'm working on the debugger, which is a major new feature that we will probably land something before the next stable. It might get that to dev earlier than that, but don't expect a date,
If
so we
you,
will let
yeah,
people know.
it's ready when it's ready. People always ask
Yeah,
stuff like that, and we always just say like, it's ready when it's ready.
yeah. So the original Python debugger was written by Andrew and also with
Glenn.
Glenn
Hmm.
somehow. We ported it to C++ as first step. Um,
A good analog is actually the very first binary ninja was written in Python. There was like this
yeah,
like prototype, and it helped test some ideas and designs and structure, and then it was like, okay, now we're ready for the real thing. I feel like the debugger is the same way, where there was a lot of good design, a lot of nice features, a lot of nice UI design, and some of like the memory elements and some of the stuff where it's um, sort of prototype there, but the Python interface was a little slow,
yeah.
and it's a separate plugin you had to enable as opposed to a first class feature. So
Yeah. So we actually finished the porting rather early, like 2 or 3 weeks ago, but we really don't target to ship it to the customer because during an internal meeting, like we say, okay, so this is actually functional, but do people really want to see or use a debugger, which is just a port of the old Python version? Because we know, okay, we spend a lot of effort on writing it in C++. We even have some clever design or some clever changes, but the end result is still the same. I mean, it has the same
I mean,
functionality,
it's
and it
faster.
also
It's gonna be
yeah, it's
faster, but
faster.
yeah,
Yeah,
I
yeah,
agree. It's like, but from a user perspective, like, so what? Like, when is it gonna be,
yeah.
something? Yeah.
So we would like to make it we would like to make it more usable compared to the old version. It's not going to be perfect. I mean, making a debugger can take years, but we will make sure that it's more usable than the old version, and we hope people will like it.
I'm curious. Actually, I haven't talked to you or the others that are working on it, but what do you have ideas for sort of like the next things you're working on that are going to be beyond what the current debugger can do? You don't have to do anything now, but if there's something that you already know you're going to do, or for sure.
So there are lots of usability improvements, like just make things happen easier. Like you can follow a pointer and show it in the memory dump. And also you can just select an instruction and say set the IIP here and continue
Hmm.
execution from here. And you can easily
Instead of having to like
convert.
copy the address, go to the register editor or double click
Yeah,
it, paste the address. Yeah, it seems a
yeah.
lot easier.
Because following a pointer somehow I mean, it's something, one of the most common thing I do while I debug. And although, yeah, you can copy as a pointer and say go to, but that's multiple clicks.
Yeah.
So to save people's time, we will have first class support for it. And also we have multiple memory dumps. That is one of the most requested feature for for myself actually, and but people really like it now because one of the things that people need is when they debug, they want to see multiple memory dumps at the same time. For example, like they have a first class, the class has a pointer to another class. They probably want to view it at the same time. So when they have multiple memory dumps, they can easily do it. Yeah,
Yeah, or if you want to like, I mean, we have a stack view, but maybe you actually just want to see the stack in a memory view while you're also looking at
yeah,
something else in memory and some global or wherever.
yeah. So these are the
My
solid,
dog, sorry.
easy. Yeah, that's fine. It's the easier changes, and we do have some high-level ideas. Like we will use the information from the debugging to enhance the static analysis. So, for
And
example,
that is one of the things that even the Python one did. I think that was unique because from the very beginning that was one of the goals we had for it. It does a little bit of that
yeah.
already, right?
So like I can give several examples. Like for example, the most obvious case is where when we debug the code, we see some code is executed, but for some reason the static analysis has not found it.
Sure.
That is pretty common, and of course we will support. Um, See, basically the debugger sees this function has been executed, and he will take note for it, and at the end of the debugging, he will say, okay, here is a list of places where it gets executed, and do you want to define function here?
Yeah,
And
and I think the current Python one you had to like step through a call into a function for it to notice? Maybe is that a difference of what you're planning the new one, or is it the same kind of behavior where you actually have to be single stepping? Or
I think the behavior is going to be the same for this
yeah,
because you have to at least let the debugger see it
yep,
to allow it to
yep.
behave.
That makes sense. Oh,
Because
although a lot of times, this is going to happen because of indirect control flow, right? So it may just be you can easily set breakpoints on all of the indirect control flow transfers in the binary, and then be a pretty easy way to recover a lot of state from something that might otherwise be hard to compute what those values are.
Yeah. And also one thing that I have been thinking about is, I mean, the Python version actually just does it without your interaction.
Hmm.
But we might want to let the user approve or disapprove some certain things. Like, for
Yeah.
example, maybe there is an indirect jump. And for this session, maybe it jumps to function A, but we know it's going to be going to function B for the next time. So we may or may not want to connect them immediately once we see it, right?
Yeah.
So we will offer a UI for people to somehow choose what they want to apply for the static analysis.
And that's actually another good one too. You mentioned indirect jumps, and that is it's not only function calls and new functions, but also new branches, right? And control flow within existing functions, where if there's things that we've missed, it can
Yeah,
also pick that out. So, yeah,
yeah.
I do like that feature. Well, I don't want to get too distracted with debugger though, because we'll probably have you some of those on later to talk about that as it gets closer to dev.
Yeah.
Tell me about, I guess, you said there were 12 challenges on the Grand RE challenge. What types of
Mhm.
challenges were they?
So they are either x86 or ARM, and they have three categories. They have anti-tampering, which is the binary is protected from tampering, and you need to change it, make some changes to it. It's like just cracking, in a traditional sense.
And by the way,
And
you've had several people congratulating you in chat already as well too. So they're
oh, I cannot say that because
yeah,
thank
no
you.
worries, no worries.
And yeah, and also they have the obfuscate, which is the most which is the largest category.
This is like
Because even
OLVM style, like obfuscated Tigris, that kind of like.
yeah, they have Tigress, which is the tool they use to make the challenge. I'm sort of familiar with this tool, not because I have source code or any kind of, because it's just because I have done some research into what it generates before. So I kind of familiar with what I'm
Was
going
that
to
what you
see.
focused on then when you started? Were you like
No,
doing that, or did you end up doing other categories?
no, I just can I share my
Absolutely. Go
screen
ahead. Let's
or
do that. That's the code is far more interesting. Go ahead and share whenever you're ready.
yeah, present now. I just make sure it doesn't follow a loop because I'm also viewing the stream, and if I stream it on my computer, I
Nope, we should be good. I got you.
yeah. All right, you guys seeing my screen?
I think they should. Well, let them
Yeah,
confirm.
okay.
Yeah, I see it on my conference monitor.
So the first thing is I have a wide screen. It's not making maybe it's not super easy for you guys to see it, but it's really an important thing for a success for reversing because a wide screen allows me to see more things. This is my personal habit, but I really like it. So this is their website, Grand RE Challenge. And yes, you see here they are announcing the results. I'm winning the first place. I haven't get the prize money yet, but I will get it.
That's right. The important part is they put your name on it. They said you're getting it, so now they can't take it back, right?
Yeah,
They've
of
already gone
course. And
public.
other people already know it, so
Yeah.
no
Now
worries.
JC in chat says they do the same. That wide monitor is critical for their reversing too. And
Yeah.
Valgrind says the wider the better. Also multiple screens.
Yeah, I think one wide screen is better than multiple screens, but this is just purely personal habits.
I think
So
so. Yeah.
yeah, we should sell a Binary Ninja packaged with the widescreen. It's like,
Binary Ninja
all right.
widescreen edition, you get like a special
Yeah.
desktop background on it just for that
Yeah,
resolution.
and also the UI works better. The default layout is for widescreen. It works better in that way.
You know, we
Um,
actually, I am curious to see what Rusty comes up with on some of the UI stuff because I know multi-monitor and like different layouts is one of the things he's trying to better account for with it.
yeah,
So
yeah,
240 hertz so you can RE faster. It wouldn't help me. My eyes refresh rate's much lower, but
yeah. That doesn't help me as well, but it might make a difference if they are super fast. All right, so much for that. So this event is a little bit different from the other CTFs you would play. It's kind of related to research because it's hosted by a research team from both University of Arizona and also Ghent and also this company. I don't know how to read it. So they ask you to install some monitoring software on the machine you actually solve the challenges so that they can collect some data on how you approach the challenge, like your keystrokes, your mouse moves, and your screenshots. So this actually scares many people.
I know. I heard early on a lot of people were kind of like freaking out over it. And it makes sense. Again, when you know the goal is for them to understand what types of protections work and don't and how people solve them. And so like you get why they would want it as a research effort. But yeah,
Yeah,
I know some people were not thrilled by that.
and because we all run it in a VM, I mean, I did a clean VM and
Sure.
installed Binary Ninja in it, and I don't think they would really get anything other than how I solve it. So I don't think that's a problem. And because I used to be a researcher, so I really like to be able to contribute to their effort on understanding the mind of reverse engineers. So I think I'm just happy with it. And other people might feel not happy with it, but I'm fine because they don't play. It means I have a larger chance to win. So
There you go. Increase your odds.
yeah,
That's fair.
yeah. Well, yeah. The situation might change in the next year because people will see after viewing this stream and say, okay, so it not seems so hard to win 5,000 US dollar. Maybe I should give it a try. So maybe the
Well,
next
well,
year.
you just need to say that all of the ones you're not going to talk about are way harder. You're going to talk about the easiest one on stream, right?
Yeah,
So it's way hard. Nobody else should participate. That'll keep your
yeah.
odds good.
And I will say that like out of the 12 challenges, I only solved 4 because I only need to solve 4 to win it. That doesn't mean I cannot solve others. There are
Oh,
actually
there we
2
go.
others that I partially solved, but I would
Nice.
say, yeah, I don't really need to solve it to win. So
Now, did you know during the competition how far through you were relative to competitors, or did they not tell you that to the end?
So they don't have a scoreboard.
Yeah.
They're not running the famous CTF system. I happen to forget its name. It's
CTFD,
super.
yeah, from Kevin Trump, yeah.
Yeah, super famous. They're using their own website, and you have to submit through email. And because those challenges cannot be graded automated, so
Mm,
of course, yeah, we don't. I don't really know how the second place is close from to
yeah.
me, and from the end result, you see actually he or she is pretty close. It's closer than I have expected. So, but you know. Uh, if I email the organizer, they will tell me how well the second place player performed. But I was just confident and I'm leading because here is one thing: is for any challenge, the first one to solve it will win 2 points, and the second one will will win 1 point. So that is the reason I only solve 4 challenges, but I win 7 points. That means for 3 out of the 4, I am the first one to solve. And for this guy, he win 4 points for 3,
Which means
and
they were
that means
first on one and second on the other three, right? So just they
yeah,
were you and that person were first and second, and all four of them basically. Or
yeah,
no, because they got three of them actually. So somebody else would have been in third place then with 1 point maybe, or yeah, however that works out.
yeah. So that's for the basic intro, and here is the description of the challenges. They have round 1 or round 2, which is not an essential difference.
Did they
So,
release them at different times, or were they still just like?
so they released 7 challenge. Oh, they only have 10 challenges. I had some bad memory. It doesn't have 12. So they released the first 7 challenges as the first stage.
Okay.
And on a particular day, the first stage ends and the second stage starts. However, interestingly, even after the second stage starts, you can still solve the first stage challenges. So it completely doesn't make a sense to have these stages
Well, I
because
mean, it's kind of time gating it a little bit. So, like, if you were going to have multiple people cheat and collaborate, intentional time delays is one way to minimize the impact of something like that. Maybe I don't know. Like, at least from like normal CTF design, I know that's a consideration.
yeah. Well, so I think today I'm going to discuss challenge 7 with everyone. It's one of the challenges that I solved using Binary Ninja scripting heavily. So I think it's a good place to introduce what you would do if you have to script something. So basically automate some of the deobfuscation. So this challenge has a category temper, but it doesn't mean this is not obfuscated.
Yeah.
So deobfuscate means the program is obfuscated and that is all. Temper means the program is obfuscated, but also temper protected. It tries to be tamper proof, but you have to break it.
So you
You
either
can
have to disable whatever tamper checking it's doing, or make your changes such that it survives whatever validation they're doing.
Yes. So basically, you have to first deobfuscate it to understand anything
Yeah.
at all. I mean, not only the protection, but also the actual logic. So they injected a segment fault in it, and the task is to fix it. So let's read it from the beginning. This two program is actually the same program they offered in ARM and x86 for whomever is familiar with
Oh, interesting.
whatever
Yeah.
yeah. So the binary read to English words from a word list, which is available for download here, from standard input and print a number to standard output. So basically, it's a hash algorithm out of the 2 English words. And the words can be downloaded. And so for two particular words, the program will crash with a segment fault. And my task is to modify the program, basically remove the code that causes this crash.
But
And
so let the functionality remain, so it should still have the other behavior for all
yeah, of
other words and
course.
just not crash on that one.
Yes, otherwise I just make it return. I know, of course, it doesn't crash, but it does
Yeah.
make sense.
You got to have some functionality checks in there, right?
Yeah, of course. They have the automated check on their end, basically. They know the ground truth and they know the old behavior and just see whether 1, you fix it, 2, you still retain the old behavior. So this kind of thing is different from other CTF challenges where you are asked to figure out a flag. It's definitely harder to look for a segment fault because a program can crash for whatever reason. They can have a non-pointer dereference, and they can have a maybe they implement certain algorithm, and in some certain cases,
Yeah.
it infinite loops and it just
Or
crashes.
Stack Overflow or any other.
Yeah.
Yeah.
So this means that you cannot really have some smart observation and just happen to solve it. You have to solidly deobfuscate it, understand the algorithm, and then figure out where does the segmentation fault happen, and then you can basically try to solve it. So
Now,
it's
were all
making.
of these binaries compiled with Tigris? Was that the idea? Is they were all were they different settings, or are they all different types of obfuscation?
I'm not sure about some of the challenges, but I'd say most of them is actually obfuscated by Tigris. This is also an advantage for the attacker because it's produced by the same protector.
Yeah.
Uh,
So if you build
the
tooling to help with you on one, it may help on the other ones as well.
Yes, yeah, and also, so this is not the first year they have such an event. So in the previous years, they don't call it Grand RE Challenge. this year they call it Grand RE. It's a big name.
It's a
Uh,
bigger event.
yeah, and
I I
also
have heard that like DARPA does challenges like the Grand Challenge, the Cyber Grand
mm,
Challenge, and the autonomous
yeah,
vehicle challenges, and they have to have a certain dollar prize pool to be called grand. So I don't know if that's the idea is that they offered more money this time, so maybe that's why they call it grand.
it could be. Uh, yeah. So let me just load this
Yeah, see what it
binary
looks
by the
like.
Ninja. Yeah. So I have already done the initial analysis for it. And here is the database I get. So this is what I get for just analyzing the binary because it takes a while to finish, and I think we'd better save some time on the stream. So
Yeah.
I just do it in the background.
Yeah, but
It's
this
like,
is untouched. You haven't changed anything. This is literally just after the initial
yeah,
analysis. Okay.
yeah. So So here is one thing that's the entry point is looking familiar to us because this really like libc start,
Mm-hmm.
and this really looks like main. And also we have this fitting or init function. So
Yep.
basically, this is actually libc start, uh, and this is main, right? All right, let's get into the main function. So I don't know how you guys feel about this when you look at this.
Doesn't look crazy. Yeah, it doesn't look obfuscated.
Yeah, it doesn't look obfuscated, but it also looks quite abnormal. I mean, like you first have two function calls that basically is nothing, and then you see a loop with some arithmetics here, and you then see some more arithmetics here. Like this is
Yeah, that's
probably a
unusual
division.
there. Yeah, yeah.
Yeah, this is pretty unusual. And as you see here, this is a comparison. This looks legit, but you see here, this Rex is a constant, but is taking a double word based on this and comparing. So this is actually a value from here, and he is taking this comparing with RDX, which is the remainder of this division. So this totally look not so normal. I wouldn't say it's abnormal, but it doesn't look really like something
The
we usually have. And
yeah,
it,
the shape of the graph doesn't look too crazy, right? Just looking at the mini map. But yeah, looking at like
yeah,
all those instructions in a row and yeah, doing math on a pointer with a constant value is unusual to a fixed
yeah.
value. Yeah.
You see here, what the heck is this? You see here, uh, so everything is just not so normal, not so normal. You see here, he's actually computing a pointer, and the pointer is actually a pointer to a
I
function
do
in
really
the
like though
code.
that Binge's analysis is like no problem, I gotcha. It just the static. It looks like the static data flow system or constant propagation was able to figure that pointer out directly.
Yeah, yeah. And of course, figuring this is out is helping us, but it's also frightening because what the heck is doing? Why it is taking a pointer, and why is all this doing this weird constant 0x at lots of f and
Yeah,
d87?
yeah.
So this is my first impression when I look at the binary. It's not super heavily obfuscated because you can see here is scanf reading something, and this is probably the loop, and
Yep.
probably so here is this function is printf. I somehow managed to figure out because so this is interesting is this part of the code. So this part of the loop to read the input and to printf. So this is the core function. Is something I already recognize when I solve another challenge
Mm,
from this event. As I said, because this is produced by the same um, obfuscator, so they are pretty similar somehow. And I immediately know, okay, so this is a loop using scanf to read, and here is printf. Of course, this is what actually happens to the inputs, right?
right, right.
So before we dive into this important function, I would like to look at these branches. So this is another thing that is totally abnormal is here. You see, once it jumps to here, this is basically just
Oh
trash.
yeah, yeah.
And also here, basically, this is also trash.
So it's either an
I
opaque
mean,
predicate or it's going to patch itself to write something else there later, one of the two.
yeah, so at this point, I have no idea whether it's opaque or it's going to be decrypted
Yeah.
somehow. This looks like a legit address, so I have no idea at the moment. But another thing, yeah, so this is the first impression, and obviously, I was thinking, okay, I don't care about what the trash, whatever the trash here. I just want to see what happens within the core function. And you see here,
More of those
you
same trash ones, maybe.
yeah, more of those same trash ones. So you see the pattern already shows up.
Mm-hmm.
Like you see here, you start from something. This is a mem copy,
Yep.
and we have a comparison which leads to trash code, and then we also have some pointer arithmetics, and then we have another comparison here, and also here this is also totally abnormal. I mean, this looks like either is opaque or is going to be decrypted somehow, because this branch is technically is legit, but I mean clearing
Yeah. Yeah.
carry flag, which is not really something I would
Immediately
expect.
after a test, like, okay, sure.
Yeah. 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 And also here, so I have no intention to understand these bulky code at the first step, because I always want to see how the what the big picture is. And here is the problem. Here is what I'm looking at, because at the end of this function, we probably end up here, because if you get here, then basically you get an illegal instruction and it just fail. So here we basically get into this function, and this function is just one instruction. It's jump rex. Okay, I immediately know this is kind of a implicit control flow. Basically, rex is computed here. So you see here, rex is taking the number rex element inside this array. I will rename it to array. And this is actually the index into the array. So basically, this array should be a list of addresses. And for this particular case, the index will be 7. So it's basically jumping to the number 7.
Yeah, like a dispatch loop.
Yes. And the next thing we need to figure out is what is the value of this array. And okay, we see this array is being used as the target of mem copy. Basically, it copies 8. The number is 0x5a and is copying 0x5a keywords into this array, and the source is here. The source is here, and you can see here. Okay, so I know something, because this is looks like all of them are addresses. And if I press 8 on it and I then press star on it, I will be creating a array out of this. And you can double click on this, and you see, okay, these are yes, these are all code. And yes, for now you will know.
They don't even encrypt them in any way.
Yeah, well, they can encrypt it, but we can also break it, so it doesn't really make it stronger. So at this moment, I'd say, okay, so this one looks like definitely solvable. Because if you look at here, this is one of the target, and you see here the same thing is happening again. It's basically this is the index, and this is the conditional, because it's a if, and they will assign the index different values based on the condition, and will jump to a different place inside of the array. So you see how this is how it.
And each of those are almost like basic blocks of a higher level machine, almost, right? So there's going to be all these different chunks of code that they're going to like wire up together, and that essentially is the machine they're operating on, I guess.
Yes. So, I forgot to mention, I am a disassembly guy. I mean, when I reverse engineer, I look at the disassembly for most of the time. I know we have very powerful IO, but for obfuscated binaries, I still prefer to look at the assembly because it can help me form a more intimate relationship with the binary. So this kind of tricks can be more easily observed in disassembly.
Yeah, and I
I
think that's
know,
fair. And I think a higher level you go in ILs, the more fragile they are to those kind of
yeah.
changes too. So I think that makes sense.
Yeah, and also one thing I really like ourselves is is we have we have good support for different workflows. Like if you like high level IO, you can look at it for entire day and you won't run into problems. But for people like me, we also have fantastic support for disassembly and also these kind of annotations. I won't feel lost at all.
Yeah, even like even those constant values that we were talking about earlier, right? The fact that the static data flow knows the constant math operations, it can show it to you right there. You don't have to go to a higher level to get that level of analysis. It gets back propagated to assembly.
Yeah, sure. All right. So the next thing is, of course, to deobfuscate this because, of course, you can see, okay, so this is 7, and I look into this table, and okay, so I find the number 7. Okay, so this is going to be the next. And okay, so this one looks like some
Ugly.
crypto or hashy stuff. But
Yeah.
you see at the end, it's going to jump into the 10th item. And
Hmm.
okay, 10th of it is here. Okay, so this is a condition. And based on different conditions, which either jump to number 24 or number 1E or number 30. So technically, you can already follow the control flow of this binary. No problem. But good luck. I mean, like if
Yeah.
you look at this, it's probably a headache.
It's like having to
Uh,
click between every basic block of a normal function and not being able to see the whole structure.
Yes, so this is totally goes against the benefit of having a graph
Yep.
because how can you even see where it is crashing? I mean, how can people even understand what this binary is doing by looking at this? I mean, so this is not what I'm going to reverse. So this is going to be some of the hashing because they calculate a hash based on two English words, but
So you can use Vengeance APIs and add jump targets from those jumps in cases where it's like a constant destination, not where if it's a variable one, right? Where the index itself is constant. And you could
the
do that, but that might make like a graph that was too unwieldy and too big at that point. So I'm curious what you did next on it.
Yeah, well, that is actually what I did.
Oh, okay. I guess good. All
It's a
right.
little bit different. It's a little bit different. We can like if it's an indirect jump like this, we can actually add a target, and Binary Ninja will draw a basic block underneath this because I say okay, so the next jump target is 0x12346,
Right.
and it will just show the basic block here. But that is the problem. The problem is it will show the basic block underneath this block. But here the problem is I still cannot see the entire control flow of this function, right? What I did is I basically patched out and I put something like this here.
Mm-hmm.
And after I do all of this, I will have a single function.
That makes sense. You got plenty of room there on those sort of stub loaders that they had.
I can show you guys the final result, how it looks like in the end.
And did you write a heuristic that looked for the base pointer and then would just patch out a certain number of instructions before that, or did you just by hand go through it? What was the?
I try to, so I will go through this later. Let me first show the final result.
Sure. And so
So
Fox
here,
asked, by the way, in chat if you use the debugger while solving.
no, I used debugger, but I didn't use our own debugger. I used GDB. The situation might change once I have my C++
There you
debugger
go.
landed.
You got your own
Yeah,
that you're used
maybe I
to.
shouldn't say that, but
No, 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 no. Tell the truth. Always more important.
so this is the same function. We are seeing here the core function. We see the indirect jump here.
Mm-hmm.
And this is the function after the
Mm.
deobfuscation. It's still very complicated,
That's
but you
actually not
see,
as bad as I expected, though. I mean, that looks reasonable.
yeah, because this is a hash function, and they are not super
That's fair.
strong
Just
hash. They
lots of
just
like loops and some math and yeah.
Yeah, and you see here, this is what I did for this particular address. Is basically I can compute the target, and I will just hard code it here and let it jump to here. And also, of course, Spider Ninja just inlined the basic block here. This is basically the seventh basic block. It's basically here. You see here, they're
Mm-hmm.
exactly the same,
Mm-hmm.
same address. And also after this, you can see here, this is probably another such thing. So basically, whenever you see a jump, it's basically my script has patched it out
Yeah, just stitched
and
it up.
send the control flow directly to the computed target rather than having it hung over on an indirect jump. So I would say at the end of the de-obfuscation, it looks like it's pretty tractable. Everything is recovered, although it's still complicated and then it's mass heavy, but it's tractable. You can start reversing. I mean,
Yeah.
if you work in a environment where it's streamlined, basically you're responsible for de-obfuscating, and your colleague will be responsible for reversing the
There
mathematical
you go.
algorithm.
Your job is
Yeah,
done. You can pass it
your
along.
job is done. Yeah, well,
Yeah.
he will still curse you, but your job is done. So yeah, I will show you how I did this, how I reached this. I have a script. Um, script. What is it called? A snippet.
Snippets.
Okay.
Yeah.
Yeah. So this
Yay.
is the snippet I use, 123 lines. That's why I only use 123 lines to win 5,000 US dollars.
There was a bit more work than that.
Yeah. Oh no, this is the wrong script. Sorry, I'm on a different computer. So this is actually the script. This is actually the script. Okay, a little bit more. 123, 43 lines. Also, these are just duplicates, so
Yeah.
less than that. Um, so now we need to actually do it. Like, patch this. Very simple, right? If you do it manually, you just go to see, okay, so this is the jump target, and I have the seventh one, and I just assemble a jump whatever target it is here
Mm-hmm.
and drop down, right? But we need to automate this.
Right.
And so here is another thing that Binder Ninja is very powerful, and where I like the IL of Binder Ninja is basically, working with assembly on this kind of things can be tricky. Like you have to first say, okay, so this function is called. So this function is just a jump rex, right? So
Yeah.
we can look for cross references of this function, and we backtrack for multiple instructions. But that is bad because
Yeah.
what if
The
the jump
compiler could
inside?
rearrange it or put something else in between or encode it as a
Yeah.
different encoding, as a different width, and then you gotta you can't go fix bytes.
Yeah, so one way to do it is use the IO. I forgot which particular IO I used. Let me see. So maybe low level. You see here. So this one, for one, the IL offers structured access to the instruction. Like
Mm-hmm.
if we deal with the assembly, we have to parse the instruction and split it
Yeah,
as a
or pull
comma.
out the
And
text, and that's ugly. Yeah.
yeah, but for IL, we just basically. Oh, sorry about that. So basically, we can have current low level IL 138.
I like seeing how you use your window layout too with that widescreen monitor. That's interesting.
Yeah,
I've never put my console on the right like that because I don't have as widescreen.
yeah. Yeah, so basically structured access for it. So basically
Mm-hmm.
we first say this is the low level IO for this instruction, and I take the operands, and because yeah, thanks for the author of this plugin. We
Yeah,
have
Brian.
this preview of the instruction. We know we have two operands, and
If
we
you haven't
take the
seen that
first one.
instruction before, that's BNIL graph is the name of that plugin. It's in the plugin
Yeah.
manager. And it's one that literally every Binja developer I think has installed. It's like the first one I always install. After
Yeah.
snippets, of course.
Yeah, and also the operand one actually has a name. It's called source. So I can also write here. It says source dot constant.
Hmm.
Right. So just structured access is the best thing for this. I mean, it's
Yeah,
much better
and
than.
you've actually in the new refactor from Peter, for example, there's an even easier way of like safeguarding it. You can, for example, say if the source is instance of a constant, like you can just check it
Oh,
because there's different types of calculations of constants that can happen, and so you can query it like, is it a constant, and then get the value out of it directly as well.
yeah, yeah. Of course, you actually to this program, if I want to write it in a robust way, I should first say, okay,
Right.
whether this instruction is a low-level IO store, and if it is, then I will say whether the source is a low-level IO constant,
Yep.
and if it is not, basically I screw up, right?
Well, yeah, but I mean, then again, you can the newer ones. There's different types of IL constants that aren't like, and so instead of having to check for every type of IL, there's actually just
Mm-hmm.
now like a they're all subclassed from one parent one,
Oh,
which is just low level IL constant, I think, or I forget the exact name of it. So when Peter's change lands on dev, you'll be able to make it both robust and also still pretty concise and easy. As before, you had to do like, is it one of this, or this type of kinds? Is it a register constant? Is it a whatever? You know, there's different types of constant values that all had some constant data flow. So it's one of the changes that's coming soon.
yeah. All right, so back to the topic. Let me introduce how I solved this. So for this particular function, I would say if I look for cross-references for this
Hmm.
function, I then backtrack a few instructions, probably is fine. Just remember, because not of the lot of the basic blocks are necessarily defined or discovered. So you see here, these are all of the basic blocks, but you can, um, okay, we did a pretty good job. We recovered all of them. But it could be a case where this entire code is not defined at all. And of course, you cannot see a cross-reference here to this function, right?
Yeah.
So basically, the first thing I have to do is I have to define a function at all of these addresses. Technically, they are not functions, but that is the way that we ask Binary Ninja to start disassembling it. Basically, you can imagine if this function is not defined at all, you never see a cross-reference to this, and
Hmm.
your processing streamline will be missing this interesting, important point. Uh, so the first thing is to define a function at every address of this. Uh,
Now I think it does that automatic. Does it do that automatically when you create them as pointers? I forget. I feel like this topic came up recently.
well, I didn't create it as pointers. I created,
Currently, but you could, right? You could change the type of those to make them all actual like pointers. Um,
yes, I
but
can do
but
it.
I don't remember if that actually triggers will necessarily create a function there.
Yeah,
Um,
and of course, so this is a script. I create a binary reader. Um, do I need to have a larger font? Sorry about that.
a little bit would help. Well, I'm looking at I think a smaller screen than some other people because I've got it. I can't resize my chat window or I'll disrupt the stream. But
How do I um
probably uh, does control page up or control shift page up or control
okay,
plus.
yeah.
Okay, there you go.
So create a binary reader and seek to the start of the jump table address.
Hmm.
You see here, I basically hard coded it here.
Yeah,
Um,
yeah, the base of it.
yeah, and seek to it, and for I also counted the number of items. Of course, I can write a loop and look for zeros at the end, but I'd say, okay, here we have the n. Why just I just dump it here? So this is the first thing I did is I create function at the address. Um,
Hmm.
um, so basically just to use the binary reader to read a 64-bit Little Indian integer and use it as an address. So here, one thing I will cover later is here I aggressively define functions at all of these places. By the end of the day, I would have to remove all of these functions.
Mm,
together. And why? It's because I really want it to be an entire
right.
control flow graph
One
like this.
function, right? Yeah.
So imagine if you have a function
You know,
here.
you're making the case that we should have a display as code potentially. Although
Yeah,
would so the reason though that you made them as a function in the first place was to make them branch
be
targets?
disassembled as code.
So, but I think you if you would have yeah, just if you want to like look at them, but if you actually just made the jump point directly, if you wrote the branch, so it wrote the jump to it, it would continue the disassembly and analysis on the fly as well,
Yeah,
even if a function hadn't been made beforehand. Like you only need the function beforehand if you also just want to see it before you do it, right?
yeah. See, but the problem is, like, see, this guy is not. Um, then you have to write a recursive script, which is harder to write because, okay, maybe on a particular ROM,
That's fair. I see what you're saying. I got you.
yeah,
That makes a lot of sense, right?
it's a lot harder to manage. So I would say I don't want to do it. And so here is what I was saying is basically if here is we have a function address, binary ninja will not inline the basic block here. It will instead say fall through to a particular function.
Mm-hmm.
So that
Mm-hmm.
is the reason why
Why you
at the
remove
end of
him?
it,
Yeah, that makes more sense.
yes.
Yeah, avoiding the recursion makes sense. I think when Peter did something similar, he just had a basically a while loop until it sort of settled, right? Until he hadn't found any more, he would just keep running it over and over, which is less efficient analysis wise, but it was just a simpler bit of code, and he didn't have to worry about stuff like that.
Yeah.
This is also something,
Um,
by the way, that I really think a workflow would be interesting in the future. Although patching honestly is so easy in this case that it might be just faster and easier. But you could also just rewrite the IL to do
yeah.
control flow that way. But
Yeah, well, yeah, so I plan to relate to the workflow at the end, but since you have mentioned it, this particular case um, is something like a wrong once scenario. It's like we only wanted to wrong once, and the results should be saved, and then we shouldn't be repeating the workflow a lot. I
that's
mean,
fair. So yeah, patching it is gets you that right because you've modified the
so
binary itself.
Yeah, so currently the workflow is executed every time. Like whenever
Right.
you make some changes to the function, it will run again, which is great because maybe you have edited the function and if it forms a particular pattern can be simplified by the workflow, which is great. We also, I think we're going to have another workflow is the result will be saved
Yeah, I have
and it
heard
will not,
Brian mention that. Yeah, I think you're right. That's an important
yeah.
distinction.
It's because, for example, like if my script runs for 5 minutes and it does the work, just the exaggeration, it only runs for seconds. But let's say
Or
if
it's a
we
bigger
have a
binary.
really,
Yeah, absolutely.
yeah, a really complicated way, and I write a fantastic script which runs for a long time and it finishes, we don't want to repeat the work
But by the
again
way,
and
I can
again.
tell you're a good programmer and you're a C++ programmer because you used a binary reader. Because I would have used
Uh,
Python just to do a BV read and like unpack it or something terrible would have been and it would have been
haha.
much slower. But it would have worked. That's how I would have done it.
Yeah, well, we should tell people to use binary reader, save some headache if people
It is
just
for
dump it in the wrong
yeah
way. Yeah.
yeah it's much faster for that kind of use case.
Yeah, especially when it's streamlined reading, basically
Yeah
reading one
yeah
after
sequential
another.
reads. Yep.
Okay, so back to the topic. So one thing for this particular function, you see here we get 74 cross references here. So basically that means maybe for every such stop, we already have a cross reference to it, which is great. Like if we just collect all of these code references
Oh,
and
you
back.
might be able to bring up the pin cross references too, which is a nice.
Yeah, I don't think I need it. I mean, I
Well,
just want
you
to.
don't. I just admit like an excuse to mention another feature. That's all.
Yeah, I can show you how do I
Shift X.
shift X. Okay. Okay. Yeah, so this is the pin cross reference. Like if you want to save all of these results and revisit them somehow, like
Yeah. There's also I only discovered this recently, but I think you can also I don't know if it's in the saved one or if it's the regular cross references, but if you select them all and right click, I think there's like a create tag or add to tag or
yeah,
something.
tag selected
Yeah,
those.
so you can actually
And
tag all of the ones with like,
uh, Yeah.
You can make a new target.
But we already have a lot of tags. Just need analysis. Yes, you can see it's actually here. It really works, right? All right. So, but I ended up doing it in a different way because um, for this particular function, they use this kind of dispatch. But I remember for some of these functions, they use a different way. Oh, so yeah. So this is the example, jump rex. So the problem is we cannot guarantee that all of the jump rex are actually this kind of thing, right? Maybe it has. Yeah, we can actually search for it. Search for text in all places. Oh, no match is
I think
found.
you've got to get the spacing right, unfortunately. So if you just copy that and then paste it, yeah, that'll do it.
Yeah. You see here we got jump rex here. This is a fantastic function, right? It's not. It's a library function somehow.
That's actually a jump table, yeah, with normal normal jump table.
And also in VF printf. Okay, so this is another fantastic function. Look at the graph.
Yeah.
This is the artwork. I didn't want to.
At least they left you symbols for libc. That would have been a pain if you had to figure that out too.
So I didn't want to play with all of these REX and see which actually is what I want. You see, it's possible. Like I use some heuristics. There's only 80 of them, and
could you just look for ones where it's a constant value? Like if binary ninja's constant data flow like knows the value of Rax, would that have been helpful?
I don't think it works in this case. Yeah, so basically, this is an array. I don't know whether our data flow really works. I really understand this kind of thing. Like if I tell him this is an array and this is the index, could it work out REX?
I don't know if the constant data flow does, but the possible value set might. So actually, if you I'm actually just curious. Yeah, if you do go into like IL and
which level of IL?
Medium, just out of habit. And then on the jump racks, bring up the console, the Binja console, and current MLIL bracket 60. I think is that what that says? And then dest possible values, maybe.
It's on intermediate.
Okay, yeah, so it is undetermined, yeah. So that wouldn't help in that case then.
Yeah, because it really, so one, it doesn't understand this is an array, but maybe I can make it understand, but I'm not sure whether it understands the index into the array. But we should. I mean, in the future, we probably should.
Yeah.
Not for today.
Yeah.
Yeah, we need to do some work by ourselves. So I ended up looking for a particular pattern is move keyword RBP0x. So basically, I search for this particular line of code, which is I just targeted this line of code.
Yeah.
And I also did some filtering to remove the noise. By the way, so this search API is also done by me, so I really trust it.
That's right.
Yeah.
It's nice when you get
so
to use your own
basically,
features.
Yeah, bv.find or text, start and search text, and you can iterate over that. Yeah. So here is.
That's cool. I've never used those search APIs from Python. Actually, that's a good reminder.
Yeah, I determined a valid range. Basically, the result has to appear inside of this range to be valid.
Yeah, just to keep it from like libc or the other functions, maybe.
Yes. So this is the way I filter out. I like the unwanted ones, and of course I log info whatever the address I get to see if it's correct. And then basically I get the function object, then basically the low-level IO function, then basically the low-level IO instruction, and then so there is another case. It's basically it has a low-level IO code. I will go back to this later, and explain why looking for this particular thing doesn't work. So looking at the script reminds me, I did have some headache here, so that is the reason why I used this search rather than more straightforward search for the IO. I have to search for the text. Because when you search for the text, for sure you will get this constant value here. But if you search for you get to here. What if there are other basic blocks in between? Like even if it's just trash, what if
Right.
there are some other basic blocks here? I mean, human can deal with this super easily, but scripting isn't that easy to deal with this kind of thing,
Yep.
right? All right. So you see here, I'm looking at the source.source.write.constant, which is not a great way to write robust code, but who cares? This is
That's
CTF.
right. That's right. That's exactly right.
CTF purpose. This not really need to be robust. Um, so here is interesting. Like, so here, um, what I'm doing here is once I get this instruction, I will try to get this instruction. This is the second part of the signature is this 0x360 is important because this is actually where it stores the index into the array. So I remember if I only search for this, I still get some noises. But if I combine these two heuristics, I will only get what I need. And here is what I'm doing is I'm looking for two instructions after this guy. Again, this is not super robust. They can insert whatever trash here. But for this particular obfuscator, it's always reliable because I
Don't
just
put
made
more
this
work than you need
observation.
to. Yeah.
So I would really like to find a case where the low-level IO go to is in effect. Let me just go through this list and see if I catch one or two by any chance, and show and justifying my reason to not use the more systematic way. It's related to a certain type of. Oh yeah, so here is the problem. Here's the problem. You see here, this is the jump REX we know. The problem is.
Yep.
Yeah.
Different pattern.
If you go back from here, you can still write a script, say, okay, how many incoming edges here do we have? If we have one, we do A. If we have two, we do B. But, it's kind of tricky to write correctly. But this is super easy. You just look for this instruction. And if the next instruction is a go to, okay, so you know we are in pattern A.
Yeah.
And
That's why you had that go to check.
Yeah, this guy is handled here, right? And this is for regular cases. And once we figure out the check IO, we just check the IO instruction. We get the so we get the offset here, and here. So basically, you see here, for every such thing, we have a index offset, which is this, and the array. So you see another offset here. When combine these two heuristics, we get really. Yeah, we're really robust way to find all of these. And if the offset is different, we see this is not what we are interested in. It's probably just something else, but have the same pattern, just happen to be similar to this. And of course, okay, so here I write robust code. You see, I check whether it's low-level IO store first, and if it's constant, I read the constant of it. This is the correct way to do it. Previously, we have more modern approach for this after the refactor, which will let people know later. And of course, after this, we just index into the array, and we have the new address, and then just assemble it. And I did some dry run before I really put this line. You see here, I assembled it, but I only log in for it and add the con. And only on the last run, I
actually wrote the bytes and then saved the binary.
Yes. And of course, I have committed undo actions, which means I can easily undo it from the UI.
That's a good point. Not a lot of people who use the API know that, but you can actually batch up a section of changes and say, all of these things I'm about to do, save into one big undo chunk. So the user can trigger your plugin, they can undo your plugin, and just the whole set of changes will all be undone, which is really nice.
Yeah. Begin undo actions and do a lot of things here. Well, some of them shouldn't be inside of this because they are just analysis, but I'm too lazy and I just make it in. Yeah, it's fine. bv.commit undo actions and update analysis and wait. and login full down. So and here, which is really important, is we undefine all of this. I can actually show you guys what will happen if I don't do this for comparative. Let's run this script a little bit.
Bunch of tail calls.
Yeah, this is original. Yeah, I cannot run it again on something that I already deobfuscated. It has no effect. That's probably causes problems. New snippet, deobfuscate. And let's call it solve. Too lazy to type all of them. Okay. Save. And you see here, if you want to deobfuscate this function, you just comment this out. Maybe do this and do this. So technically you can write a script that iterate over all this automatically, finding all these tables and deciding the address and automatically. But I think that is too much of automation. I mean, we have 8 of them, and I do it manually. It's fine. If you have 1,000, maybe you have to find a way to automate it. So, which function is this? Go back to the function. So okay. So this is the core function. Let me do it. Wrong. It takes a while. Yeah, you see
there
it.
It is. Yep.
Yep.
I just realized another way you could have done that too for some of those branches would be to use user-informed data flow. Like once you calculate the value, you could set the value of the destination. Maybe I don't remember it would depend on what the minimal val looked like. But if there's a minimal val variable there, you could.
Yeah, it might work. That. So I will show you. I will first undo this. Edit undo. You see my undo action actually works. It's reverted to exactly the same state before I run it.
And you can redo it.
That said, I still recommend you save your database before you do such kind of things. Let's see if I remove this line. Oh, I cannot comment using the shortcut, but I just write this.
Oh, I need to add that to snippets. You can indent at least if you select a chunk of code and hit tab. I don't know if you noticed this. I had this a little while ago to snippets.
Yeah, you can tab it correctly, but you cannot comment it correctly.
What hotkey did you use to comment?
Control slash.
/ Okay. Yeah, I'll add that. That's a good idea.
So you see here, this is already the end result after the deobfuscation. It's 100% correct. Jump to this function. And you see here at the end of it, jump to this. It's still correct. But it isn't very helpful.
Because the other function already existed, so it just shows it as a.
Yeah, you still have to click 1,000 times to just get to the actual target, right? You still can get mad for it because it's not the best way to do it.
Yeah.
Right.
But by removing the functions, the only thing left is the basic blocks or the control flow, which will just cause it to all be part of the same function.
Yeah. And of course, I will undo this and remove the comments. All right, save it and run. Wait for a few seconds. Yeah, okay, great. It works. All right, okay, so I'm going to save this. This is how I deobfuscated it. I think I will stop here because this doesn't solve the challenge, but it will. This is the highlight of how I deobfuscated. There's still a lot of work to finish it, but I will just briefly go through it. So this guy, why is computing a function pointer to the start of the function? It's actually trying to checksum it. If you read this, I read this assembly code to understand this is calculating a checksum, and the comparison here has to be always to be true. So of course we just patch it to always branch.
Oh, that's a perfect use case of binary ninja right there.
Yeah, patch to all. Because the program, the task asks you to fix a crash, and let's escape how we find the crash. We already find the crash, but we need to patch it to fix it. But the binary is hashing the functions, and if you don't patch it, once you fix it, it will say Binary
It'll
is
still
patched.
crash because it's gonna jump to the garbage code after the
Yeah,
hash
yeah,
fails, after the checksum
yeah.
fails.
So yeah, this hash isn't super robust, especially because at the end it uses such a obvious comparison and jumps into trash.
Yeah, you
Like
could also
if
just actually fix up the checksum too if you really wanted.
yeah, but you know,
It's
that's
easier to
not the
right click.
hacker way of doing
That's right. That's right.
it. Yeah,
That's too clean.
yeah, that's not too clean.
Or you could hit E and then just change it to a JMP or like so many easy ways to do that.
Yeah. All right, so I think that's it. I
That's
wouldn't
perfect.
say tell people how I actually find the crash to allow me to have some advantage in the next
Oh,
year.
you're gonna keep your edge. All right, all right. Here, I'm gonna switch back
Yeah, just
to video here. You can go ahead and cancel screen sharing.
yeah, just joking, but the part for the crash hunting isn't really exciting, so I'd like to skip it. I mean,
Yeah, no
yeah,
worries.
it's not really.
People can ask you more on Slack if
Yeah.
they want to know more. Ask in the Binary Ninja Slack.
Yep.
It's really
All right.
interesting. Well, yeah, thank you very much for joining. I think because it's a late one here, I'll probably actually save Binary Ninja Basics for next week. Any questions from the chat that stayed up with us or got up depending on your
Yeah,
time
please
zone?
read it for me. I cannot see it.
I
I'd
don't
like
see,
to learn.
I did see one that mentioned that they really liked the undo somebody who wasn't aware of that undo API so that you could control how undo actions happened in a plugin in particular, right? Like I think that is a
Yeah.
nice thing that not a lot of people know. I'm glad you did that. Um, and it's also worth pointing out that those patch APIs, you can actually call the patch APIs as well directly. You can
Yeah.
just say, "Hey, here's a Valgrind. Thanks for staying up with us. Get some rest, and we'll see you in a couple weeks." Um, but yeah, that you can directly call the patch patch for this architecture, and it will just give you the bytes to write directly over the jump as well from the API. But
Yeah. So yeah, you do remind me that like this, if this binary has 1,000 functions and it's protecting each other, so maybe the first function is hashing all the other 999
yep,
functions,
yep,
and the second one is doing the same. What would you do? Like because there are only 8 functions and I patched them manually. But if that is the case where we need to do a lot of patching, we might need to do the same thing for finding the point of the check, the comparison, and also do the patch programmatically, which we will use the patch API. So yeah,
yeah.
things can be tricky when it scales up. I mean, like whenever something we do it for only once, it's easy. But if we
Exactly.
do it for
As soon as you do
for
it
1,000 times,
a bunch of times, then it's worth writing code. Yeah, and there's a lot of different ways. So somebody in chat mentions that it's KIGF or KLGF. My font's too small on my iPad. Mentions that they never would have thought of just rewriting the jump, replacing it with a hard coded assembly. And there are other ways you could do it. So I think you might be able to use like minimum of Lyell transformation. You can user informed data flow in Binary Ninja. The problem with that is it's only going to show you that on the ILs. So if you do prefer assembly and you want to kind of rewrite it, you would either have to do something like the workflow APIs, which are still a little bit new, that we demoed 2 weeks ago, and rewrite the assembly again, or you would have to just do the patching like Xusheng did, which is definitely
yeah,
like quick and fast, and especially, I mean, part of your goal is to produce a modified binary here too, right? Your not goals if your goal is just understanding and you prefer the ILs, then maybe just a workflow that modifies IL or user form data flow makes the most
yeah,
sense because you just want to look at it in IL anyways. But if you have to emit a patch binary, then I think doubly so assembly is the right thing to do, and makes sense.
yeah. And of course, in other cases where it might be hard to find enough places to patch the binary because the jump is 5 bytes. What if the original binary used the 2 bytes short jump?
Mm-hmm.
Or these kind of things can happen. It's a topic we are going to address in the future, I guess. Maybe I don't know.
Yeah, we've got an issue
Yeah,
called smart patching, specifically for that, where you could be able to make a targeted patch.
yeah. And more ambitiously, whether we can, let's see, if the user modifies the medium level IO, can we actually descend into the disassembly?
That'll be a fun way, yeah, to re-emit change native stuff. It's definitely not been. We've intentionally kind of stayed away from anything like going the opposite direction. But one day, I
Yeah.
think that will be something we do one day.
Yeah, people will want to do it in the future because they can say, okay, I already made my patching. Please generate disassembly, so my game cheat can work.
So your
You know,
perfectly legitimate accessibility enhancement, you mean? It's meant to give you,
yeah,
improve your color correction in the game, whatever it is. Anyway,
yeah,
all right. Well, thank you, yeah, very much for stopping in. Thanks everybody else who joined us on the stream. Look forward to seeing y'all in a couple more weeks, and we'll have more stuff to talk about. So, thanks again,
yeah.
Xusheng. We'll catch you later.
Yep, I will try to bring more write-ups and maybe share more with everyone here.
I like it because it's
You,
less work for me. I can just hang out and watch and ask you questions. So it's certainly easier for me than my than preparing things. So I'm more than happy to have it.
yep, yep. All right. So much for today. I'm leaving, and have a good day, everyone.
Sounds good. We'll talk to you later. Bye bye.
Bye bye.